So we've been talking about factoring. This slide right here in the beginning of the week probably was pretty confusing to you. The beginning of the week, or beginning of this section that we did, you probably were like, I don't know what half that stuff is, Mr. Martin. I said, just write it down, don't worry about it. But let's come back to it, kind of put this all together. The way that you attack factoring from now on is you first try to find a what? And we should all know what a greatest common factor looks like. When I say that, that should pop up in your brain what a greatest common factor is. Yes? Okay, now, special cases. We're going to try something right now. And again, it all depends on your effort and if you try. If I say dog, what happened instantly to your brain? Someone said wolf. He's still playing with that little toy. What else? Don't say your ex-girlfriend, that's not nice. You repeated dog.
Spelled dog.
You spelled dog. Huh? What else? You have a picture of a dog pop up? Picture of a dog popped up, right? Like, when you hear words, your brain automatically goes to that bank of everything that you've experienced, and it kind of pulls it forward. And you start thinking, so if I said, give me some characteristics of a dog, we should all be able to describe a dog, right? Well, when I say perfect square, there's some characteristics that should come to mind, that should pop up. That first term, if you're thinking about a trinomial, 3 terms, what do you know about that first term? I wrote it on the board yesterday. It has to have a, say it louder, it has to have a square root. What do you know about that back number? It has to have a square root. That middle number, how do we get to the middle number? You take the 2 square roots, multiply them together, and multiply by 2. I know this happens. Just like I know about a dog. It's the characteristics of it. I also know that that back number has to be positive. When someone says difference of squares, something pops up in my brain also. What pops up? What's the big tell in difference of squares? 2 terms. There's only 2 terms. The front number has to have a square root. The last number, second number, has to have a square root. And the middle has to be a what? Subtraction sign. Yes, negative, subtraction, whatever. All of this should pop up because that means that you really know what you're doing. If it doesn't pop up, you're probably not going to be successful at this because, like I said, it's not a guess and check game. It's not like I'm up here going, I'm going to throw a 3 in here and see how this works. That's how I was taught, and it sucked. That's not the way I've presented it to you. I've given you a direct way of how these work every time. So we go through, we find a GCF, no, it doesn't work. We go through, it's not any of these special cases. We then look at what? When I say look at A, up here on the board, there's A right here. That's what I'm referring to when I say look at A. The number in front of, and that should be x squared. The number, or that's called the coefficient in front of the x squared. You look at it. If it's A is 1, that's that short way that was real, double bubble right away. Same sign, different signs. Either I add or subtract to get to my middle number, multiply to get the last number. Everybody kind of understand what I'm referring to, yes? Okay? Now, if A doesn't equal 1, that's what we're going to get into today. And that will be everything for factoring that you should have come in kind of really not knowing and kind of being able to do. You should have to be proficient, which is what we're striving for right now. So what happens when A does not equal 1? We got 2x squared plus 11x plus 15. What's my first step I'm supposed to do? Is there a greatest common factor? No. Second thing I'm supposed to do. Is this a special case? And how do you know right away it's not? Say it loud. This doesn't have, 15 doesn't have a first square, but even before that, 2 doesn't have a perfect square, right? So that's not a square. There's no, I can't take the square root. It'd be pretty, right? Does 2 have a square root? Yeah, it's ugly. It reminds me of you guys, right? It's not pretty like me. If it was a 4 there, it'd be a nice pretty number like 2. You get the connection there? Okay, good. So that's not going to be a perfect square case. It's not going to be a difference of squares case either. Yeah, leave it up. That'd be fun listening to that all day. So here's the way that the last thing I do is I look at what? Not yet. Look at A. A is a 2. Is that 1? No. So here's the process for when A does not equal 1. So what you do every time. The first step is you take this 2 and you multiply it by 15. 2 times 15 is what?
30.
Now, 30 is not going to be a part of our equation. It is not going to somehow transport itself into the equation right here. It is not going to be a part of this equation at all. So 30 does not go over here at all. It's just a number I'm going to use to find some magic. And I'm saying it's magic because it's crazy how this works out. It works out every time. It's going to have the same pattern. You'll see it as we do this problem, hopefully. So 30 is a number I'm going to use to help me solve this problem, but I do not put the 30 over here at all. The reason I'm harping on that is because I've seen a lot of kids take this 15 and replace it with 30. You can't do that. What has been my whole thing in math? Are you allowed to change values?
No.
You're just allowed to change the way things. If I take a 15 out and I put 30 in its place, I've changed the value. Everybody sees that, right? Okay. So you can't do that. But you remember how we used to do when A was 1? I said I need 2 numbers that multiply to 15, but since they're same signs, they add to 11. Do you remember me doing that? Well, I can't do that because of this 2. The 2 screws everything up. It's probably a girl. Anyways, it's just a joke. I don't mean that, girls. Back off. Quit your fiery darts with your eyes and just relax. Gosh. All right. So, 30 is going to be my number that I'm going to use, not 15. Meaning I need 2 numbers that multiply to 30, but add to 11 still. So this still means same signs, and it still means add. The only thing that's different when A is not 1 is I got to use a new number, which is 30. And how did I get that 30? 2 times 15. And that's the number I'm going to use to multiply to. So I need 2 numbers that multiply to 30, but add to 11. And what are they? All right. 5 and 6. Now, here's where the part of this thing comes in. Remember how I said we change the way things look, we don't change their value. You see this 11 right here. I can rewrite 11 a whole bunch of different ways, can't I? I can write it as a 10 plus 1, 8 plus 3. But do you see how I found the 30 and I knew that this was 5 and a 6 are going to get me to that 30 and to the 11? Those are going to be the numbers I'm going to use. I'm going to change 11 into a 5x and a 6x. And it doesn't matter which one I put first. It will work out the same. The magic will still happen. 2x squared plus, would you like me to put the 5 or the 6 first? It does not matter.
6.
I heard 5 first. Sorry. Do you see these 2 things are the same still? This is the right here, 2x squared, 2x squared, and 11x, and right here, what is that value still? 11x, and this is still a 15. I have not changed any of the values of the things up here. Are you with me? Okay. We're about to do something again. That, remember when I told you in middle school you learned about these properties and you never used them, and you thought they were stupid. The first one I did was community property. Do you guys remember any other properties that you had? Okay. Equivalent. Yep. That's fine. What was that one? How in the heck do you use associative? Associative says that you have 2 plus 3 plus 4, which equals 9. But if you do this using order of operations, you're supposed to go 2 plus 3 first, which is 5, and then 5 plus 4 is the 9. That's how you're supposed to get that. Well, with addition, you're allowed to go, you know what? I don't want to do it that way, Mr. Martin. I want to add the 3 and the 4 first, then add the 2. And you know what you still get? 9. That's called the associative property. It works with multiplication and addition. Do you see how technically this is one number right here? And I'm supposed to add a 5x, then add a 6x, then add a 15. Now, after I do that, I can realize, you know what? I don't want to add this, and then this, then this. I want to add these two together first. Then I want to add these two together. And then I'm going to add all of it together. That's the power of the associative property. That's why I'm allowed to put those two sets of parentheses in, is because of the power of the associative property. Does everybody understand what I'm talking about up here? Now, with this bubble right here, do you see anything that they have in common? Do you see a greatest common factor between 2x squared and 5x? Do you see a greatest common factor? They have an x. Do they have a number in common? No, 2 and 5 don't have any number in common, but they do have an x in common. So let's pull that out. When I pull that out, what am I left with? 2x plus 5. How do I check that? X times 2x gets me to my x squared. X times 5 gets me to my 5x. Any questions on that step? Plus, what do these guys have in common? 3. Here's where you should see some magic happening. 2x plus 5. How in the world does that happen? You have a 2x plus 5 here and a 2x plus 5 there. That has to happen. If that doesn't happen, you done did something wrong all up here. You made a mess of something. And you got to fix it because this has to happen. Now, here's the last part that's kind of, now we're getting to big boy and big girl school. You're going to hear me say that a couple times today because we're really understanding math. Do you see this as one number? Eventually, if you put an x in here, you times it by 2, you add 5 to it, then you'd multiply it by that same number, and it would become one number. So is everybody okay with that being one number? Do you see this as one number? Now, right up here, do you remember how this was one number and this was one number? And we said, hey, they have an x in common. Let's pull that out. You understand? Greatest common factor? What do these guys have in common that we were like, holy cow? What do they have? They both have a 2x plus 5. That means that is their greatest common factor. They have that in common. So guess what I can do? Pull that out. 2x plus 5. And guess what I multiply that by? Whatever is left over, which when I factor that, this kind of, I don't want to cross it out, but I've kind of used that. That's right here. So what's left over is my x, and it goes right here. And then what's left over in this one is my plus 3. And boom, there it is factored. If you take this and you do this times this and this times this, that's a great question. That's what we talked about in the beginning. If you FOIL that back out, this will get you right back here because, again, all of this stuff is equivalent. Nothing up there that I changed the values of it. I just changed the way it looks. How do we think? Thumbs up, sideways, thumbs down. Any questions on this so far? Yes.
So if you don't find like any special cases that you can't get like a GCF, you just like run the first number, run the last one, always.
For this, yeah. For right now, that's what we're gonna do. We're gonna talk about other cases later. That's gonna be algebra 2. Algebra 2, we're gonna get to some eventually that are gonna be not factorable, and then we get this formula that helps us find stuff later on. So it's all building. But for you right now, if you understand this process, we're gonna look into other cases. Like, how do you know it's not? We'll get there.
All right.
So I don't ever like saying yes and no's to like, oh, never, this is the only thing. Because it's not. Math is, it's a big world. It's a big world to try to define it. It's small. Yeah. Yep. So what you're saying, what you guys are trying to say is, if there's a number right there and you can't get rid of it by GCF, or you can't get rid of it because it has a perfect square or difference of squares, this is the process that you do every time. And now notice I called it the long way, because when A was 1, remember I could just double bubble, and I found my answer real quick. Or this way, it's the longer way. So that's why I name it the longer way. Is it really harder? No, it just takes a little bit more practice, maybe. But it's still definitely doable. How are we doing so far? All right, let's get to some other stuff that can happen, because math, you always got things that can happen. All right, we go through this again, real quickly, right? GCF, no. Special cases, no. 3 doesn't have a square root, okay? Look at A. Is A 1? No, it's not. And I am A-okay with you going like this. Dang it. I get the same thing. I look at a problem, and if I get to, you'll see, when we start doing stuff, and we have to use our factoring, I'm going to go, man, oh well, let's roll with it. Here we go. It's okay with that. I'm okay with you saying that and being real in your head. So here we go. 3 times 20, that's what we said we got to do every time, is what? Is 60 going to transport itself into this equation at all?
No.
No, it's just a number just to help us find this magic. That's it. Nothing else. What do I need?
10 and 6. So, I mean, like, you need 2 numbers that come to 60.
Yes, 2 numbers that multiply to 60, but why add to 16?
You can also, like 16, but you can also subtract, like, it could be, like a 6 minus, no, just do something.
No, you're on the right track, but hold on.
It could be a 6 minus 10.
No, what?
Negative 6 minus 4, negative 20, positive 4.
That won't work.
Wait.
Listen. Remember, we're playing the game. Hold on. There's a bunch of numbers that get me to 60. It's going to be negative 10 and negative 6, but let's talk about why. I don't want the answer. Answers don't help us. I mean, I get that answers are like, but I need to know why. What does this sign tell me? Same signs, and what does that mean? It means you add. That's why I'm saying I need 2 numbers that multiply to 60, but add to 16. That's the key that I was looking for from you. I need that sign recognition that says you're going to add to get to this middle number. Because in my next example, we're not going to be adding. We're going to be subtracting, because there's not always adding to get to the middle. So you need to know, how do I know whether it's adding to get to the middle or subtracting? It's not guessing. It's this sign right here that lets you know which one you're doing. So that's why 10 and 6 are going to work, because they do multiply to 60 and they add to 16. Are we with me on the whys? Again, I'm going to rewrite this. 3x squared. Now, just like some of you have said, the value of this 16 is negative. So when I rewrite it using my 10 and my 6, I still need them to get me to a negative 16. The way that's going to be possible is a negative 6x and a negative 10x. Because when I combine those, that still gets me to that negative 16. And then at the end, I'm still going to have plus 20. Is everybody with me on that so far? Now, the negative signs are going to be little boogers. If you've been in math long enough, you know negative signs can kind of make things a little bit sticky. I'm going to show you how to deal with that negative sign. I would do this every time with my negatives, or else you're going to mess it up. When I go to associate it, I put my parentheses here, and I put my parentheses here. Now watch what I'm going to do. This is only with the negative sign, because negative, if I put my parenthesis here, please watch how that changes that problem. Do you remember when you have to distribute a negative sign? So now that negative belongs to the 10, but I also accidentally made it belong to the, which totally changed my problem, changed values. And remember, everything I do, it can't change values. So that's no bueno. So I don't put my parenthesis sign there. I put my parenthesis sign here, but I can't leave that I can't leave this together because that looks like what? Multiplication. So what can I put in there? A little plus sign. That won't change any value. Remember back in middle school, hopefully a teacher told you adding a negative is the same thing as subtraction. So all I did is I added a negative 10. That's all. That's the only way I kind of manipulated that piece of that problem. Are you with me? That's the only tricky part of that problem. Now what do I do?
For the first one, factor out 3 into this.
Perfect. Find a GCF between this one and this one, which is 3x. What am I left with? X minus 2. Because 3x times x gets me to that, and 3x times that gets me to that. Now, remember how we knew that our first bubble had to be the same exact thing as our second bubble? You can kind of cheat now. You can kind of go, I know my bubbles have to be the same. What is my x here? Bless you. What is my x here? Positive or negative?
Positive.
If I only factor out a 10 here, what will my x be in this bubble? And I want them to be the same, so that's not going to work, is it? So how can I change it? And by the way, my 2 is supposed to be what? Negative, and my 20, it would be positive. So when I factored out a 10, it would still be a positive 2. They wouldn't match, the bubbles wouldn't match, and that's, I have to make the bubbles match. So that's how I kind of cheat this, and I go, Well, what if I factor out not a 10, but a what? If I factor out a negative 10, then negative 10 times what gets me to a negative 10x? What's the only thing I'm missing? An x. Isn't that what I wanted to match so far? And a negative 10 times a what gets me to a positive 20. A negative 2. And doesn't that match now? Isn't that so pretty? Yes, sir. Right here? It's still, remember, just think of it as you can plus anytime. So if I write this, 5 minus 2, I can rewrite that as 5 plus a negative 2. Or I can rewrite a 5 plus a negative as just 5 minus 2. So I could re-put the plus sign in here, and then that would be a negative 10, or I can just leave it like that.
Okay.
Does that make sense? Now, what's my final step? I look at this total number here and this whole number here. What do they have in common? They have an x minus 2 in common. And I bubble and I say, okay, what's left over in the first one? Well, this is kind of use. 3 is left over. And 10 is left over. And it's a negative 10. So make sure you put that subtraction. Boom. There it is, factored out. And again, like he asked, if you FOILed this out, you would get right back here because all of this is equivalent. That's all we're doing in math. Changing values, not changing values, changing the way things look. That's it. How are we doing so far? Thumbs up, down, sideways. Come on. Absolutely. If we get time, I'm going to ask you guys to make a problem with me. because I think that I hope that helps you figure out where I'm getting these numbers from, because I'm making them up in my head. How did I change this problem?
You have two negatives.
There's a negative right here, isn't there? Which had been always a plus sign. So does it change our beginning steps? What do I still look for first? GCF. Do these guys have anything in common? No. By the way, you could have a greatest common factor and then still end up with a number up front. And so you might have a greatest common factor and an A doesn't equal 1 problem, just so you know. But I would still attack it the same way. Just a couple more steps, that's it. So, greatest common factor, no. Special cases, this one could be a special case. Why?
Because you have 4 has a square root.
4 has a square root, 9 has a square root, so we should check it. Square root of this is 2x. Square root of this is 3, but then I look at this and I go, wait, that was really stupid for me to even check. And it's okay. Why shouldn't I even actually have checked it? Yes. Because right here is a negative sign, and what do I know has to happen in my special case? So you know what? Forget it. I realized I made a mistake. No big deal. It can't be a perfect square. That has to be a plus sign. Everybody follow me the way that I'm checking this stuff. Second thing, how do I know it's not a difference of squares? It's got 3 terms. Now I look at A. A is not 1. As soon as A is not 1, I multiply 4 times 9. 4 times 9 is 36. Now, I circled that negative, and I talked about this in the last problem. Why is that negative so important to me? Now it's going to be different signs, which means I need to subtract. So I'm looking for 2 numbers that multiply to 36, but subtract to 9. 12 and 3. Now here's the other, this is where it's so much thinking, but if you get the concept of, I'm changing the way things look, but I'm not changing their value, and you keep that in the forefront of your brain, this next step won't be too difficult for you. Yes, sir?
Why did you put the 36
Because my next step, I'm not worried about that. I think that gets more confusing when I make that a 36. I'm going to take care of that negative in just a second. That's what my next step is talking to you about. So when I'm telling you, we're about to replace this 9, right here. We're about to replace it. We're going to use this right here. There's 2 options. I know that they're going to have different signs. The 12 can either be positive or negative, or the 3 can be positive or negative, but one of them has to be positive and one of them has to be negative. When I want to replace them, I need it to be left over with a what? A negative 9. So which number is going to be my negative and which number is going to be my positive? Does everybody understand why 12 has to be the negative? Because when I write this down like this, when I combine these, does that get me to? A negative 9x. If this 12 had been positive and I had wrote this as a negative, what would my value have been? A positive 9, which would not be equivalent, and there's where I would have made my mistake. Is everybody okay with that step? My second thing to keep you from making a silly mistake. Do you remember how that negative was a pain in the butt the last problem? Remember how when the negative was back here, I had to put the negative in there and add, so I had to like put the parentheses way out in front of here and put up another plus sign there? Do you remember me doing that? Because of that negative sign that was here? In the last problem, you guys know what I'm talking about? Okay. Do you see how when I had the choice of putting the negative first or putting the negative second, where did I put it? So I don't have to deal with that sticky situation. If I get a choice of whether I put a negative first or put a negative second, I always put a negative first. Now sometimes, like we saw in this example, you're not going to have a choice. There was a negative here and there was a negative here, so I had to learn how to deal with the negative, because there's no way to get around it there. But in this problem, I can at least save myself the headache of having to worry about the negative by putting it first. Do you understand how I'm setting myself up? And this is math. This is it. This is like where you are literally thinking through and going, this is why I'm doing this. I'm going to help myself out by putting this forward. Associate these guys together. What do these guys have? What do these guys have in common? A 4x. What am I left with? X minus 3. Just think, when we first started this GCF, you guys didn't even really know too much, about what it was. And now you're using GCF all the time, huh? What do these guys have in common? Plus 3. And what am I left with? And again, that magic happens. X minus 3, the x minus 3. And I pull that out, x minus 3. And what am I left over with? A 4x plus 3. And again, if I FOILed it, that would get me to the same thing that this can get me to. Now I'm going to draw a case up here just to show you what can happen. I'm not going to make a whole problem of it. I'm going to show you the factored part, the bubble part. So let's say I have this, 2x plus x minus 7. And over here, my bubble is already an x minus 7. So let's say I do all that work above this. I do all this work. And I get left with this. Is everybody where I'm at in the problem? And I've associated, I pulled out the greatest common factor already, and then I looked here, and there was no greatest common factor. But I see, hey, this has an x minus 7, and this has an x minus 7. That can happen. Well, that's what we're going to talk about. What is right here is a plus 1, and it's not going to be written. You're not going to have that written there. You're going to have to see things. Again, there's another reason that mathematicians are weird. You see things that aren't really there. There's no 1 there, but you see it there. Okay, you see things. You're like that kid from that movie. I see dead people. Guys, is that too old of a reference? The Sixth Sense?
Bruce Wilson.
Willis.
Yeah.
Yes. Got it. All right. So it would become factors. If I wanted to factor this, it'd become x minus 7. And then in my other bubble, does everybody understand that what would be left here is a 2x, and what would be left here is a plus 1, and you cannot forget that plus 1. Did we pick up what I just put down on that one? These are just special things that can happen. They're weird cases, but when someone explains them to you, it's not that big a deal. But when you come up on that on your own, you're like, what the heck am I supposed to do here? Don't freak out. Just throw a 1 in there. No. Your 2x is left, and your 1 is left. Any burning questions? No? We'll start.